Okay, welcome back. Today we're looking at LeetCode number 1936 called Add Minimum Number of Rungs. It's a medium question, and so we are given a strictly increasing integer array called rungs that represents the height of rungs on a ladder. We're also currently on the floor at height 0, and we want to reach the last rung. So we're also given an integer called dist, and we can only climb to the next highest rung if the distance between where you're currently at, so the floor or on a rung, and the next rung is at most distance. We are also able to insert rungs at any positive integer height if a rung is not already there. We want to return the minimum number of rungs that must be added to the ladder in order for you to climb to the last rung. So if we think about this with an example, so if I just draw a ladder here, and let's just add some rungs, maybe some there, and we'll have a bit of a gap in the middle, and then our last one up here. And so 0 is at the bottom, let's say that's 1, that's 2, let's say we skip a few, that's 6, 7, and 8, and maybe our distance, we'll just call d for now, maybe that is equal to 3. So what we want to find out is how many rungs that we may need to add to get from 0 all the way to the 8 up to here, moving at most a rung distance of 3 at a time. So in this case, if we just look at it intuitively, we can see that we can start at 0 and we can go to 1 and we can go to 2, but we can't make it to 6 with our distance of 3. The most we can get is to 5. So in this case, let's take our best approach, which is just to go 3 up anyway, which means we will have to add a rung 3 units above our current rung at 2, which will give us a new rung at 5. So now if we travel there, we're at 5, we can go to 6, we can go to 7, and then we can go to 8. So here we can return 5. So let's just look at this through a more algorithmic approach. So what we really want to do is just climb the ladder and see where we can't get to the next rung, because we know for sure we have to add at least one rung somewhere there. In this case, we know we have to add a rung somewhere between the 2 and the 6. So how do we do that? Well, the main question is pretty much how many times can we fit this distance of 3, or this block of 3, between the 2 and the 6. So you might be thinking there might be some division involved, and you would be completely correct. So what we want to do is find out how many times we can fit our distance into each gap between each rung of the ladder. So to do that, first off we need our gap, which we can call g, and all we would do is take the height of our next rung, which in this case is 6. We can just call that n for next. And we want to minus the height of our current rung, which in this case here is 2, which is c. Now, as this is an exclusive gap, as in we want the distance between 2 and 6, not including the next rung, we just want to get the gap is the next rung, take the current rung, take 1. And I'll explain more in a minute just how that handles an edge case for us. So now that we've got our gap, all we need to do is divide it by our distance, and that will give us the number of times that distance fits into the gap, as in that's the number of times our newly added rungs can fit into the gap. So all that is gap divided by distance, and that will give us our rungs we have to add. So if we wanted to go through the whole ladder, we could just keep a counter, we could just call that our result, and we could just at each step just add our gap for the current 2 rungs divided by our distance, and just add that to our result. Let's consider another example. What about when we're starting on the floor and we can't even get to the first rung with our distance? So we know the floor's at 0. Let's say the first rung is at 4, and then 6, 7, 8, and say this is 11. And let's also say that our distance is 2. Now all we have to do in this case is find the gap between our starting position, so 0, and our next rung, which is at height 4. We know that the gap here is just 4 take 0 take 1, which is 3. And now what we want to do is just divide that by 2 by our distance, which just equals 1, which means all we have to do is add 1 rung. We don't have to know this for the solution, but by intuition, we know that we can add a rung at height 2. Now, if we go from 4 to 6, our gap is 6 take 4 take 1, which gives us 1. And now if we divide that by our distance, we get 0. Here's the edge case, which sort of explains why we had to minus the 1 from our gap. If we didn't do that, we can see here that 6 take 4 is 2. If we divided that by the distance, we would still get 1. However, we know that we don't have to add any rungs here. As our distance is 2, we can go from 4 directly to 6. Now if we go from rung 6 to 7, we know that our gap is equal to 7 take 6 take 1, which equals 0. We know divide 0 by distance, no matter what distance is, that will equal 0. Now we just do the same thing from 7 to 8. That's exactly the same case pretty much as the previous one, which also equals 0. Now we go from 8 to 11. Now our gap is 11 take 8 take 1, which gives us 2. Now we divide that by our distance, which is 2, and that gives us 1, as we have to add 1 rung between those two in order to get to the 11. We know again just by intuition, we don't need to know this for the algorithm, but we know that we can add a rung at position 10 there. And if we were keeping a counter of all these results on the left here, we know that we can just add them all up, and then we would be able to return 2, and that would be correct. If you have any more questions about the reasoning, feel free to leave them in the comments, but now let's move on to the coding section. Okay, so first of all, we just want to initialize our result counter, so we can just call that result res for now for result. And as we want to iterate through each element in the rungs vector, we can just keep track of the size of that so we don't have to keep recomputing it. Now to make this a bit more simple, we can also initialize a variable to keep track of the value of the previously visited rung. And we can start that at 0 as we're starting on the floor at height 0. Now we want to iterate through each element of rungs. We can do that just using a range-based loop. So we can call each value rung, and it's contained within rungs. So we can just do this. So now we want to find the gap between the current rung and the previous rung, -1. So we can call that a gap. And all we would have to do is have gap be equal to rung take prev take 1. So next we want to add to our result counter the number of distances that we can add inside this gap. So all we do is add to res our gap divided by our distance, and then all we do is just update our previous rung. So all we would do is just have previous equal rung, and then after that all we have to do is return our result, and that should give us the correct solution. Before we submit that, I've just realized that we don't need our size variable for our iteration, as we're just using this to iterate through using our for loop. Let's submit that and see how we go. We can see that our runtime beats 90% of other users with C++. Although the LeetCode runtime is not always completely reliable, that's still a good sign, as we've gotten the optimal solution. Our solution here has the optimal space complexity. To find a few optimizations, maybe we could avoid storing the gap and just doing the whole operation in one line, but it's always good to have readable code, especially in an interview. If you have any other questions about today's problem, the algorithm, or my explanation, please do not hesitate to leave any questions in the comments and I will get to them as soon as possible. If you enjoyed this video, please feel free to leave a like and subscribe if you enjoyed and you would like to see more. Comment any feedback you have, and I will see you in the next one. Thanks for watching.